Hello students, how are you? Now today we are here to discuss about vector analysis, that is basically vector algebra, then products of vectors, unit vector, then resolution of vector, and then the resultant of two vectors. Now first of all, before we start, let's discuss about what is a vector. Now when we talk about physical quantities, so there are generally two kinds of physical quantities. First is a scalar quantity and second is a vector quantity. Now what are the differences? How do we identify that which is a vector or which is a scalar? Right? Now the vector quantity is defined as those quantities which has magnitude and direction both. Now what does it mean? Being a magnitude means, let's suppose if you are moving in a direction with a particular speed like 50 meter per second and you have a specific direction like in this direction. Are you getting? Now if we are specifying the direction also with the speed, so that becomes a velocity, and velocity is a vector quantity. But when we just say that you are moving with 50 meter per second, so that is just a speed, this is not at all a velocity, right? Means vector quantities are those quantities in which there is a magnitude and a direction. But on the other hand, the scalar quantity is having only a magnitude, right? Now let's understand it. A vector and a scalar. Vector quantity having magnitude and direction, right? Both. But in a scalar, only magnitude now no direction. Right? I hope this point is clear. Now for example, we can say that velocity. Now when we say velocity means, let's suppose we have 100 meter per second north. So here we have a direction, of course, and we have a magnitude, right? But on the other hand, when we say just speed, right, means 100 meter per second. Now the speed doesn't have any relationship with direction, right? Now 100 meter per second speed means it can be in any direction, we are least bothered about it, right? But when we say that the velocity is 100 meter per second means now there is specifically the magnitude and the direction, right? Means north, right? That specifies your vector quantity. Is the point clear? Now for example, we have a force means 100 Newton force in south, right? Or let's suppose if this is a block, so we can say that F is equal to 100 Newton and this is the direction, right? This is the direction on the block, right? So this is basically the vector and scalar. I hope the point is clear. You can note it down, right? Now, let's understand that what is a product of vectors. Now, let's suppose we have a two vector A and vector B. They are two vectors, right? Now their product can be defined as their product. First is dot product and the other is cross product, right? Now dot product specifies as A dot B, right? A dot B. However, the cross product is defined as A cross B, right? Now dot product means we have to put a dot in between A and B, and cross means we have to put a cross. Now these are two operations. Now dot product is defined as this is equal to modulus of A, right? Then modulus of B, then cos theta. However, A cross B, basically the cross product of two vectors A and B, is defined as, of course, modulus of A, then modulus of B, and this is sine theta, and then this entire value is multiplied with a unit vector, right? Now, what is this modulus? Now, modulus A and modulus B are the magnitudes of vector A and vector B. Correct? So this symbol is basically known as modulus A, which is equal to magnitude of vector A, right? And modulus B is equal to, of course, the magnitude of vector B. Are you getting? Right? And theta is the angle between vector A and vector B, right? Theta is nothing but the angle between vector A and vector B. I hope this point is clear. Now, what is this eta? Okay, if you have noted it down, so we can further mention this. Eta is basically a unit vector, right? Now this dot product will give a scalar result. Are you getting? But cross product will give you a vector result, right? Means the quantity that you are getting after multiplying these two vectors as dot product, this particular quantity is a scalar, right? But on the other hand, in cross product, you will be getting that this quantity is a vector. So that's why there is a unit vector multiplied, and this one is the scalar one. So making it a complete vector quantity. Are you getting? So that's a cross product results a vector quantity, and dot product results in a scalar quantity. Is the point clear? Right? Means अगर दो वेक्टर का डॉट प्रोडक्ट अगर हम लेंगे तो उससे हमें एक स्केलर क्वांटिटी मिलेगी, और अगर हम दो वेक्टर का क्रॉस प्रोडक्ट लेंगे तो हमें एक वेक्टर क्वांटिटी मिलेगी. राइट? आई होप दिस पॉइंट इज क्लियर. Now we have the same two vectors, vector A and vector B. Let's suppose this is vector A, right? And this is vector B, and this is theta. Correct? So A dot B is defined as, we can simply write modulus of A modulus of B into cos theta. Correct? Which is of course AB cos theta. If modulus of A is equal to small a and modulus of B is equal to, correct? Now look at here, if this dot product has been given to you, right, and the magnitude of vector A and magnitude of vector B has been given, correct? So you can find out the angle in between the two vectors, yes or no? Correct? Now for example, let's suppose if A dot B is equal to 2, correct, and modulus of A has been given as 1 and modulus of B has been given as